This video is about midsegments of triangles.
So we're going to use this image to discover the definition and properties of triangle midsegments. A midsegment is drawn on this triangle. The outer triangle is called ABC. It's red in this picture. And one of the midsegments is drawn, and that's DE, this little blue segment. Now, a midsegment in a triangle has a lot of special properties. We're going to discover them using the coordinates of this triangle on the coordinate plane. We want to start by using midpoint formula to discover something. We're going to also use the slope formula to discover something. And we're going to use the distance formula to discover the third property. This is a good review of all three of these coordinate geometry formulas. Let's move to another slide where there's a little bit more room. And here's the same image, a little bit smaller, and we want to label the missing coordinates. So C is located at 0, 0. It's just not filled in. E, if we count over 3, is located at 3, 0. And D is located at 2, 3, right? Because it's the point right here where it intersects with the side of the triangle. So now we have some key coordinates labeled, and we're starting by using a midpoint formula to discover one of the properties of DE. Let's remind ourselves how we find a midpoint. The midpoint is, of course, the coordinate of the point that is halfway between two other points. So it's basically the average of the two x values and the average of the two y values, right? x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So we're finding the average of 2 points. So let's find the midpoint of AC. The coordinates of A are 4, 6, and the coordinates of C are 0, 0. So to find this midpoint, it'll be 4 plus 0 over 2, and 6 plus 0 over 2, which is going to be 4 over 2 and 6 over 2. So the midpoint of AC is located at 2, 3, which of course on this picture is the point labeled D. The midpoint of BC uses the endpoint B at 6, 0, and C again at 0, 0. So to find this midpoint, we want to do 6 plus 0 divided by 2 and 0 plus 0 divided by 2, which of course is 3, 0. And if you find that on the graph, that's the point that's labeled E. So we have this point D and this point E are the midpoints of two sides of this triangle. And when you connect the two midpoints together, you form what's called a midsegment of a triangle. So that's the definition of a midsegment. So midsegment of a triangle, midsegment connects, as we just proved using our coordinate geometry, the midpoints of two sides. So that's the definition of a midsegment. It's the segment that connects the midpoints of two sides of a triangle. So there are other midsegments in this triangle that are not drawn. There is no midpoint labeled for the line segment AB, but if we were to put one, looks like it would be about here. We could draw another midsegment there and another midsegment there. So there's actually 3 midsegments inside of every triangle. I'm going to get rid of those just so that they don't confuse the work that we're doing here. So we've just discovered one property. We want to discover another property using slope. I think I'm going to add this to a new slide so that we don't have to write over the work that we just did. All right, so let's paste our picture in here. So this time we want to find a property using slope. So let's find the slope of DE. Remembering the coordinates of DE, 3, 0, there's 2, 3. So the slope formula, to remind ourselves, is a single fraction. It's a constant that tells you how steep a line segment is. And you find it by doing the difference in the y's divided by the difference in the x's. So y2 minus y1 over x2 minus x1. So the slope of DE is going to be, let's remind ourselves, the coordinates of D, the coordinates of E, and then fill in the formula. The second y value minus the first divided by the second x value minus the first. It's going to equal negative 3 divided by 1, which is negative 3. And I also want us to find the slope of AB, because that's where we're going to find the special property. So the points AB are 4, 6, and 6, 0. Let's fill them into the slope formula. It's the second y value minus the first over the second x value minus the first is negative 6 over 2, which is, of course, also negative 3. So we have the slope of the midsegment and the slope of the third side of the triangle being the same, which means these two segments are going to be parallel to each other. I'm going to show that on the picture with these two green arrows, right? These two segments are parallel to each other. Let's write that property down. So the midsegment of a triangle is parallel to one side of the triangle. And if you see on the picture, so DE is the midsegment that connects the midpoint of AC to the midpoint of BC. So which line is going to be parallel to? The third side, right? That wasn't used in forming the midsegment itself. So the midsegment is parallel to the other side of the triangle. And then we have one more property to discover. And this property we want to discover using the distance formula. So the distance formula, to remind ourselves what that is, square root the difference in the x's squared plus the difference in the y values squared. It's basically the Pythagorean theorem. So let's start by finding the distance or the length of DE, which is our midsegment line. Remembering that D is located at 2, 3, E was located at 3, 0. So the distance is going to be equal to the square root of the difference in the x's squared plus the difference in the y's squared. It's important that you do what's inside parentheses first, leaving parentheses around them before you square. So we've got 1 squared, so it's negative 3 squared, which is 1 plus 9, which is the square root of 10. Can't simplify that any further, so we'll leave it. And then let's find the distance or length of the segment AB. Let's write the coordinates of AB. A is 4, 6, and B was 6, 0. So when we apply our distance formula, it'll be the difference of the x values to the second power plus the difference of the y values to the second power. Simplify what's inside of the parentheses first, then square both of them. They should come out both positive when you square them. So 4 plus 30. 4 plus 36 is the square root of 40. And this can be simplified by splitting 40 into 4 and 10. And then, of course, the square root of 4 is 2. So this ends up being 2 root 10. So if you look at the relationship between this length, which was the midsegment, and this length, which is the opposite side that, it's parallel to, we see the relationship of the distance being doubled. So we have the relationship that DE, the length of DE, is equal to half the length of AB. So to write that property out, scroll down where I have a little more room. Midsegment is 1/2 the length of the parallel side of the triangle. And there are the 3 properties that I wanted us to discover using coordinate geometry. Now we're going to apply it to some situations like this one. We are given a triangle QRS, and then we're told that we have these midpoints T, U, and B. That means that all of the segments that connect T to U to B are the midsegments of this triangle. So like I showed before, every triangle has 3 midsegments. So the midsegments in QRS are segment TU, that's one midsegment, UB, that's another, and TB, that's another midsegment. What are the lengths of TU, UB, and QR is what it wants us to find. So we have enough information based on what they're showing us on the picture. The first thing I see is that I'm given the length of TB, since I was already inside the triangle looking at these midsegments. I see that I'm given the length of TB is 30, and that means that the side of the outer triangle that's parallel to that one must be double that because of the relationship that we just discovered using the distance formula. So that means this right here must be double 30, which of course is 60. And now I found the length of QR, which was one of the 3 things it wanted us to find. So the length of QR is 60. It also wants us to find the length of UB. So when I look at UB, that's this segment right here, I can see that this is parallel to the QS side of the outer triangle, which means it must be half of the length of QS. QS is labeled as 50, therefore half of that would be 25. So the length of UB is 25. And then it also wants to find the length of TU. So TU, I'll go over it in blue here, is this midsegment, which is parallel to this side of the triangle, and therefore must be half of that length. Since SR is 40, then TU must be half of that, which is 20. Applying some algebra to that same thing. So if you just look at the picture without even looking at the questions, they show all these congruency symbols. All these congruency symbols tell you is that you have a bunch of midsegments drawn. So because JM is the same length as MK, that means that M must be the midpoint of the side. And then same thing for N and same thing for O. We have 3 midpoints of 3 different sides, and therefore the segments that connect them are the midsegments. So I'm going to label on the picture what it says in the question now. It says if JK, which is this whole length here, is 5x plus 20, and NO, which is this midsegment here, is equal to 20, what is the value of x? So we need to be able to write an equation. We only have one variable here, and that's x. We just need to write one equation that is true, that has x in it. So in this picture, it looks like because NO is parallel to JK, it's the midsegment that is half the length of JK. That means that NO times 2, which is, of course, 40, but I can write it like 2 times 20 for now, is equal to the length of JK. This is just one way to set up the equation, but it has to be based on that relationship, the fact that NO is half of the length of JK, or doubling NO will give you the length of JK. And then you solve this equation for x. So 20 equals 5x, and of course x equals 4. That's all it wanted us to find. It doesn't have us plug it back in, just wanted us to find the value of x. And that is all.